Hello everyone, this is, well, Mr. Barden again with another video lesson here. This will be the last one that I'm making before I'm planning on being back physically in class. In fact, if things go according to schedule, I should be back kind of towards the end of the week. On whatever the last day I'll see you all that week is. Um, so let's just kind of hop into it. In the previous ones, we've kind of mostly been focusing on a lot of basic concepts. Nothing should have been too nuts. Kind of just going up through the coordinates and the canvas. So when I'm back, I'll kind of do a quick 1 day review, make sure everyone's up to all on the same page. But this bit that we're going to be starting with is going to be over variables. And this is a very important part of just coding in general. And it's very important that everyone understands this concept and how it's used, because this will be used throughout the rest of the year. And if you do any coding outside of this class, this concept will stick with you and be something that you use for as long as you're doing computer coding. And it's going to be something that a lot of the things are going to be built off of later in this unit. So again, this is a very important bit of material. I'm going to be going through these two lessons right here on variables and math today, and we'll hop into the code as needed. So up until this point, anytime we've had to do stuff with the code, making shapes, making whatever, we had to hard code it into the code. And that being that if I wanted to put in, let's say I wanted to put a circle right in the middle there. To do that, I'm gonna have to do that. I've put all the numbers here, and these values are what's called hard coded, meaning they will never change. They're hard like a rock. To change any of these values, though, I'm going to have to go into the code and manually change them. There's no way for them to change and update while the code is running. And kind of keep it in mind whenever you're using a program or something that someone makes, you're not looking at the code, you're looking at just the rendered result whenever you're using an app or playing a game or anything with the code itself. You're not actually looking at this code. So, to have these things update and change, we need to utilize what is called a variable. And I've already used a few of the things I'm going to talk about today in the previous video. I just didn't explain what they were. So to do that, there's some steps. And you can see there's some examples here. I don't know where that is, but there's some steps to follow for how to make and use a variable. And I've got these listed out here in the textbook. So if you want to see this more in kind of a step-by-step bit of instructions to follow, or if you just want to see it at some point later, you know where to find it. So to make a variable, I just first want to talk about what it technically is. If you've taken algebra and other math classes, the term variable may be familiar, but it doesn't behave the same way as it does in math classes. So to use that, I normally come in with a Tupperware or a lunchbox or something, but what I've got next to me that serves this purpose is my bright pink water bottle. So what I've got here is a water bottle. It has some water in it. Cool. And it's all there. This is going to function like a variable for the purposes of this demo. This is the variable. It contains water. I can look in it and say, yeah, there's water. So anywhere in my code, we can just say, hey, use the contents of this container in the code here. So we can say, all right, cool. It's, I don't know, 10 ounces of water, give or take. A little bit. And then at some other point be like, yeah, that's still 10 ounces, or I could take some out. And you're like, oh yeah, that's about 8 ounces of water now. Again, I'm ballparking. There's no like markers on here. And so on. I could completely take it out. I could put orange juice or coffee or some other thing in here. The point is, this is a container that is going to store something that we're going to look at and use later on. That's the metaphor I'm going for with this. Um, so whether it's a thermos or maybe a lunchbox where you put in a turkey sandwich one day and you look at it and say, yeah, that's the turkey sandwich, we're going to use that at lunch, and you take it out and you can use it, maybe take it out, put something else in there if you change your mind, and so on and so forth. You can put these values in the variable to be stored and used, and we can update and change them whenever we want. That is the core of what's going to be happening with the variables here. So to do that, I like to go right to the very top of my code, right when the code starts, and we're going to type the word let. Let is used to define the variable, so we have to tell the code that this thing exists. We have to say that this exists, this bottle, this container, and we have to give it a name. I don't actually have a name tag on here to illustrate that, but it exists and it has a name. So we have to give our variables a name. I'm going to say circle size. And I have now declared the variable. I have said it exists. This variable is here. It's cool. It's a thing. The next step, once we have declared it, and by giving it a name, is we have to initialize it with a value. And to do that, we have the equal sign, which is used to assign a value. And then we can tell it whatever it's going to be. So I'm going to say 100 for right now. So we have now stored the value 100 inside of the variable circle size. So in our code, wherever we want to use that, we can just say circle size and circle size. The result right now is the same thing, but maybe we wanted to change this to 500. That's really big. I was kind of going for 50. And so on. And you can see that this is changing and updating in all of the places that we're using it. We don't have to use it there. We can say use it wherever you want. So maybe that's a thing. And now as the circle gets bigger, the screen also gets brighter. So that could be a thing. And so on. I'm just kind of messing around at this point. But the point is, you can store the variable and give it a name, and then just refer to it by that name in your code. It's very user-friendly. You don't have to remember all these numbers. You can manage one spot in your code, one value. It makes it very easy to change stuff and have it affect multiple things. Makes it very easy to change some things, and you don't have to change a whole bunch of values if they're all kind of related to each other. We're basically just kind of abstracting away from working with the numbers as the main level, but the numbers are still important. So they are going to come back. In fact, we're going to have a whole half lesson on numbers and math. So again, we have now declared the variable right there. And initialized it with a value. I want to point out a few things, though, is that you can only declare a variable once, meaning you can only say let one time. If I was to go in here and say let we're getting problems here, and it actually says it in the errors down in the console that circle size has already been declared. So you cannot have two variables with the same name. So that wouldn't work. I'd have to make a different name for my variable. So that's the core to that. Again, you cannot have two variables with the same name. To kind of go along with that, I have right here a bunch of very not good variable names. So speaking of names, you can name them basically whatever you want. The only real rule is you can't have two with the same name, and they can't start with a number. Those are the only two real rules. But looking at this little black bar right here with some bad variable names, can you tell me what any of those are supposed to do? That's a rhetorical question. I can't hear you. I recorded this like 3 weeks before you were going to see it. And I already know the answer. That answer is no. Because what you should do, and I intentionally made these bad, is make your variables describe what they're going to be used for. And I did this up here. The circle size is used to control the size aspects of the circle. And I'm going to put this back at 220, just so that way it's being used properly. If I wanted to maintain things, we could say, let the background color be assigned, I don't know, 100. We could just say background color like so. That was just a quick example. So we can do it like that, but then we can set up our code to change and update things automatically by altering these values. So I'm going to go into my draw function, and we're just going to do a bit of typing. Instead, we'll say circle size equals frame count. Just like so. So you notice that this circle is getting bigger and bigger and bigger, and technically it's just going to get bigger for infinity. But what we're doing is we are taking that variable name and we are assigning it a new value. In this particular case, it's just the frame count is another variable we're going to talk about in a second, but it just counts the amount of total frames that the code has been running for. And so that's just a number that's going to be ticking up and up. We're going to store that inside of circle size. And since we're using circle size right here, it all fills in. So I'm not touching this at all. The computer is just automatically doing it. So that's the key here, is that you can utilize, all of, these to abstractly represent the value being filled in to this argument. But then we can do stuff to it. We can replace that value with another one that's being used to draw stuff or update things. And that's the core bit that makes this very powerful and very useful. I want to go through a bit more of the textbook here, and we can see some of this in action. So this code right here, that's we can still see most of that. We've got a box, and then this box that's kind of randomly moving around, and we can kind of see what we've got right here. So we've got, we're making this variable let the rectangle height, there we are, be assigned 50. We are also only declaring the rectangle width here. We are not defining it at all or initializing it. We're just declaring it. So you can just say make the variable, and then later on we can do stuff with it. You don't have to do it up here like I've done, where I declared and initialized them on the same line. We could just say and then it's there. We don't have to assign anything to it until later on, but we've allocated that memory for the variable. So then down here, just to break this down, we gave them some really thick outlines, and then we set the frame rate to be 10 frames per second. So we slowed down this bit of code. And then over here, we're saying, okay, the rectangle width, that variable, is being assigned a random number in between 1 and 400 every frame. We can see it in the console if the console popped up on this view. And then we're drawing the rectangle using those variables. So every frame, so 10 times every second, this pink rectangle here is getting a random width, and that's being used to redraw the rectangle, so we see it, kind of randomly moving around. That's kind of the end result of this. We're just putting a new random number into this variable, into this container, and then later on we're looking into these containers to see what the values are to draw that shape. Okay, so that's the main bit right there. This next bit is an important distinction and a helpful tool, and these are system variables. So system variables are, well, variables. They behave just like what everything I've mentioned so far. The only difference is you don't make them. They already exist in P5 as part of the system. All right, they already exist. They already automatically monitor their stuff. You do not declare them or initialize them. They are always running in the background. So I've got a few right here that we can look at. Um, why's this? Should be seeing. There we go. Let's just be acting up here. Um, so here we're using mouse X and mouse Y in two different things. So one is the position of that third point of the triangle. I'm using the mouse location for that, but I'm also using it to control the colors. So you can see how that triangle is changing colors as I move it around. And you can see that just right here. We're doing some math to it, which I'll talk about in a second, but we're just taking that mouse X and mouse Y variable to do stuff. So I've got listed here a few helpful system variables that should be pretty useful. So mouse X, mouse Y, that's just the location of the mouse on the canvas in that frame. The P mouse X and P mouse Y is the mouse's location on the previous frame. Key and key code actually got put into the chart backwards, but that's okay. We can work that out. I mostly use key code, but that's just a numerical value that says whatever the last key was pressed was. The width and height of the canvas. If the mouse or a key is pressed, these are all pretty useful. That formatting was weird. The last little bit I want to mention before I'm talking about math is just the idea of global and local scope. So this will become a bit more obvious as we do more and more of this, but basically, as I've done it here, is how we'll probably do it for most of the class, and that is making these variables globally. And this means that we have declared them, and they can be used globally, meaning in any function. So I could reference these variables in any function in my code. It could be these, it could be other ones, it could be whatever. This is different than a locally declared variable. So if I went into my setup function and said let, I don't know, circle y equal 15, and then wanted to use it down here in my circle y slot, this would not work because we've declared this locally inside of a function. In fact, we're going to get this error here that says circle y is not defined, but we did define it up here. That's because, again, this is local. We can only use this variable inside of function setup. So if I were to take this and move it up here, it works just fine. You saw it all fixed just how it should. And the reason for that, again, is because up here, these are all being defined globally. They are not inside of a function. So technically, you could declare things, let Bob equal 10 and let Sally equal 17 and let mixtape equal fire. We can we can do this wherever as long as it's not inside of a function. And a lot of times you'll see variables kind of spread out, but I like to put most if not all of mine at the top here, just so they're all in one spot so I can see them all right at the top. And if I need to make any changes to my global variables, I can just do it. And it's all right there. I don't have to scroll through increasingly long bits of code, up and down, all we go. There we go. Fix that. just to find one little thing to change. It's all kind of living at the top, and that's kind of a useful tool to have, I believe. But this code here is kind of explaining all of that a bit more. So there's a commented line right here, and it basically just is giving us errors in the code. Otherwise, I'm going to let you explore this a bit more if you want, but that's the core to it. Most of the stuff we'll do here was just fine with it being global. Um, most of the stuff. There's times when that won't be the case. Okay, so if you want a little more practice, there's some stuff you can do right here to practice with that. But I want to talk a bit more about math. So yes, we're abstracting away from the numbers a little bit and using words to represent a stored value, but we can still do any kind of math to it that we want. It's all a number at the end of the day. And that applies to, you can be as complex as you want and create, super complicated algorithms for doing stuff. That's what a lot of these functions really are. But we can also just do basic math. So I've got here on the canvas 12 squares being drawn, but they're all being drawn with math. So I've got a variable that's controlling rectangle X and rectangle Y, and that's kind of the base level. And then down here in the draw function, I'm drawing each of these rows with a different math operator. So, rectangle plus addition right here, multiplication, and then subtraction, and then combining multiple ones to get different options. So it looks just like a simple grid, but we've all done some math to it. And I can change this. Maybe I want to make this 50. Just rerun 50. Yeah, and then we can start to see some of these things begin to change a little bit. Because again, this is all built off of that 10 as the base. So that all gets to change. And we can see this in a bit more action down here. So instead of keeping it as 10, I'm just resetting them every frame to be equal to the mouse X and mouse Y. And the math down here is the same. So we can see that as I move things along, some things follow at a fixed distance or percentage. Some have a exponential growth, things like that, and it affects both of these dimensions. So you can see all of these relationships moving around, and it just depends on how we want to utilize them to get what we need. So that's about it, give or take, and so on. So again, the math can be used to just change and apply different numbers. So a quick little handy tool. I'm going to get rid of some of this extra stuff I don't need. And instead of doing 200, 200 here to put my circle right in the middle of my canvas, I knew that because it's by default 400, 400. But what if my canvas is a weird size for whatever reason, but I know my circle is always going to be in the middle? Well, we can do a little bit of simple math to always get the exact middle of the canvas. And that would be width divided by 2 for the width and height divided by 2 for the height. And just to break this down, again, width and height store the current, width and height of the canvas. So that number represents this bottom line and this top line and this right line. So by dividing them both by 2, we're going to go, half of the top, half of the width. It's always exactly in the middle. So I can change this to be 800, and it's still going to be in the middle. I could make this 680. It's still going to be in the middle. I can make this 375, and it's still in the middle of the canvas. This automatically updates, but that keeps that positioning the same because it's all abstracted out to be this relationship with the screen. So again, that's a very useful trick for just putting something, boom, right in the middle of the screen, regardless of what the screen is. Window width and window height is just the maximum amount of space you could fit on your screen. Um, okay, so that's there. To do some really basic animations, we can use something called the modulo and a few other variables along with it. So modulo, if you're not familiar with it, um, will be the math that we're going to use. But I'm going to actually wait just a second and kind of actually just go through these codes a bit before we actually dive into that. So to do things, I've got a shape drawn here using an arc. It looks like Pac-Man. And we've done a little bit of math to move that Pac-Man. I mean, it's pretty simple. We're just moving it. We're decreasing that X value by 2. So we see the Pac-Man move to the left. There it is, as we go. But if you were to look through this, there's no background being drawn in the draw loop. Okay, it's being drawn one time in the setup. So we can see all of the old Pac-Man's shapes still on the screen. It's kind of like a, again, this is functioning kind of like a flip book of all the different frames on top of each other. But since there's no background, we can see the old Pac-Man. That's just to show that this can draw and loop. But we can loop these values over, and again, just to get the Pac-Man moving, by drawing the back. Why this hates me. By drawing, the background is highlighted. You can see that it is now being drawn every time in the draw function, and the Pac-Man moves, and we just see that shape moving. That was what was happening earlier when I moved the shapes around before. We're just redrawing the background over the old frame. Okay. So there's math. There's some compound symbols for math to do that. So let's work our way into it. I've got this basic animation, but it's pretty boring. Circle size equals. I'll make it a kind of small circle, and I'll put it at here. Equal 100. Circle y equal, I don't know, 25. Let's move that down a bit, and let's also make this a lot smaller. So like, there, just so it's a little smaller and easier to work with. So I want to make this circle move. That's the goal. So we can do math to it, just like we made it grow. So we can say circle x gets assigned like so. And we're now seeing it move. Now, if you've only taken math classes before, this line may be very confusing to look at. Again, it's a little bit different than math. And the way it works is that we're going to take circle x, that value, and we are going to assign it the current value of circle x plus 1. And I think this becomes a little bit more clear if we just console log circle x. We can see that it's increasing by 1 every frame, and since we're using that to draw the position of the circle, we see that that circle is moving, and then by slapping the background on it every time, it looks like the circle is moving. I don't know why it seems so laggy right now, but we're gonna go with that. There we go. Okay, I mean that's the idea for making things move. So we can do plus 1 divided by 1. I don't know. That's actually going to do nothing. Yoink. Multiply is the asterisk for that exponential movement. Minus, it just removes the opposite direction, and so on. So we can set that up to be whatever kind of math we need. It's great. If we want to have things kind of be cyclically animated, where they move in a repeated pattern, that's where that modulo comes back and becomes potentially confusing. I'm not going to be too worried if you don't get this quite right away. Again, this will be the day that I am coming back into the classroom, so I'll be able to answer questions. So to do that, we have modulo. Modulo makes these cyclical animations. And it kind of goes through here, and we can see this in results, in action right here, where this rectangle is repeating its circular motion. I can't talk anymore. So to do that, maybe we want to have this circle move in a similar pattern. Well, what we can do is just some basic math to the contents of this variable. So circle x, only instead we're going to say modulo an amount. Let's say 100. Oh, I forgot a step. There we go. Okay. So now what we're seeing is this circle is repeating its pattern. So I'm going to put this on the screen, and I'm going to explain what modulo does. So let's say that you have some numbers and you want to do some division. Let's say you have 3 numbers and the number 3, and you want to divide that into the number 1. Well, 3 goes into 1 0 times with 3 left over. Okay? With me so far? Let's say if you want to divide into 2, 3 goes into 2 0 times with 2 left, or sorry, it was 1 with 1 left over. 0, 1, 1 left over. 3 goes into 3 1 time with 0 left over. Okay? I've got to point to this. 3 goes into 4 1 time with 1 left over. 3 goes into 5 1 time with 2 left over. 1, 2, 3, 4, 5. And it goes into 6 2 times with none left over. 1, 2, 3, 1, 2, 3. The modulo is when you divide one thing by another, but instead of getting the normal division result, we get the remainder, and that is the number that we look at. There's tons of videos and more in-depth explanations of that, but basically we are dividing A by B and taking whatever is left over as the result. So the frame count is just always going up. And then, I don't know why this is very laggy. I guess it's just because I'm recording all of this at the same time. I don't know, my internet's been acting up too, but whatever. But anyways, this is here. So what we could do to kind of see this is I'm going to add frame count here. And you'll notice that every time that there's a multiple of, or it gets to, there we are, 74, it's got that that much left over, this second value, but this is the actual frame count on the left. So as it gets to 99 with 99 left over, and then we get to frame count 300, now we're back at 0, and it goes again. And since we're using this second number is the one that's being used to draw the circle, that's where we get this cyclical repeating. So every time the frame count is a whole number multiple of whatever number we give it here, we will see that that shape is jumping back to the beginning. So I could just do width And now we should see that this circle is moving across the screen. Again, I don't know why there's so much lag, but then it restarts when it gets back. Um, and I have like barely, I'm using like 7% of my computing power, so this has to be the internet acting up here. Um, Whatever. Um, but yeah, that's the idea. My internet's been acting up recently, and it's annoying. Um, but that's the core of it, is that we are taking one thing, dividing it, and then getting that remainder, and that's what we're using there. So again, anytime there's a whole number multiple of something, we can see that repetition happening in the animation. So explore that a bit. I've got some practices here. So what I want you all to do is to go through these two pages, the variables and the numbers, read through the read through them on your own, and try the variable, like all the little let's practice bits. Um, if that sounds good, also give a shot at some of these assignments. The one that I've given you all to start with is the simpler of the two, I think, and that's the one down here. More or less, it's basically the same assignment. But if you go and were to look at it, what I'm looking for, let's see, week 3 assignments, is to, on your canvas, draw 4 different ellipses. Okay? And then use mouse X or mouse Y to control, to draw those shapes. So as you move the mouse, we should see those shapes move in different ways around the screen. And then apply some math to that as well. So that way we see them all behave in a different way. They should all be unique. Make them unique. Try the different math operators and go from there. But they should all follow the mouse in some unique way. I do not want to see a circle just follow the mouse. They should all have some kind of math applied to them in some way. And that's it. It's very similar to this second assignment down here. So if you wanted to try this one as a practice, you should be fine to do the other one. If you want a little more practice with the modulo, you can attempt this assignment up here, this chapter 1 review assignment, but be aware this is going to be something that I'm planning on having the class do. I'm going to say this as if you're looking at this in the same week, week 3 of classes, but next week when I'm here for the first full week, we're going to work through this one as part of our review of everything so far. So if you want to take a crack at it, you can, but just know that Monday or Tuesday, I'm looking at my calendar, the 29th or 30th, so whatever that last week in August is, I don't have the AB schedule yet, so I don't know if I'm going to see you all on Monday or Tuesday that week, but whatever day that is, I'll hide myself so you can see the day. So whatever day that is, we'll go through all that as a bit of a review. So if you want to give it a shot, give it a shot. If not, that's okay. I'm starting to ramble. But that's the core of it. Again, like always, turn in your codes to this assignment. There's a bell ringer. I wanted to make these few weeks, still going over content, but as simple as possible, just because, again, I am not there. So again, if you have any questions or concerns about this or any of the other material, shoot me a message on Remind, on the Discord server, leave a comment on this video on the YouTube channel, check out the other YouTube videos. There's tons of resources available for you. And then again, I'll be showing up soon. Again, assuming you're watching this during actual week 3. And we'll work it out. I'm not too worried, and we'll go from there. So that's going to be it for me for this lesson, and I will see you all hopefully very soon, but definitely I'll see you the next time I see you. Bye. I hit the mouse and didn't click the stop recording button. Now, bye.